Hello, Trig students. Today we are going to be looking at one of our last ways to simplify some trig expressions, and this uses your favorite thing. All right, your favorite thing in the world, fractions. We are going to be adding some fractions together, subtracting some fractions together, getting a common denominator, and that will allow us to simplify some expressions. Again, we are just flexing our algebra muscles here, using everything we can to apply some trig identities. All right, so today is going to be making fractions, combining the fractions with a common denominator, and then simplifying. A quick reminder, your homework is due tomorrow, and I'll figure out some way to give you a little quiz one way or another. Unfortunately, I haven't been able to grade your last quiz because I haven't been able to come to school to pick them up, and they're still sitting either on my desk or somewhere. I don't know. But yeah, let's do this. Let's do this. All right, so using fractions, common denominators, to do some simplifying. All right, number one here, we got sine of t plus cotangent of t times cosine of t. Now, at first you might think, well, Bolt, where's the fraction here? We don't have any fractions here. All right, but we can make one here. Cotangent, right here, cotangent, is cosine over sine. Look back, find that identity if you need to. So we've got sine of t plus, all right, cotangent is going to be cosine of t over sine. And then we still have times cosine at the end, bring that down. All right, well, the fraction on the right, of course, this cosine here is actually on the top, right? That is technically cosine over 1. So we'll rewrite this as sine of t plus, on the top we've got cosine squared over sine. Now, what if I wanted to combine these two into one fraction? Well, we can't add, I can't add these two things. Oh, that didn't work too well. Until they have a common denominator, right? So what I have to do is I have to make this first term here have a denominator of sine of t. So the old trick to do that is to multiply by the denominator you want. All right, and you have to multiply it by the form of 1 because you're not actually allowed to change anything. So I'm going to multiply that by sine over sine. I don't have to do anything to the right side. Excuse me. So just the left on this one. All right, once we do that, we'll get, let's see, on the top, sine times sine is sine squared over, now I do have my denominator of sine, plus the second fraction, which is still just cosine squared over sine. Now that they have a common denominator, we are allowed to add the numerators. All right, so add the top sine squared plus cosine. What? Sine squared plus cosine squared. Awesome. Hopefully you can see what that's going to do. So on the top we have sine squared plus cosine squared over sine. The numerator, hopefully you're recognizing that one by now. Sine squared plus cosine squared is 1 over sine. And 1 over sine is simply cosecant. And there we have it. So that whole thing simplifies down to cosecant. All right. This next one works almost exactly the same. Okay, so maybe pause the video here, try it on your own. See if you can do number 2 without me. I'll continue on and work through it here in just a minute, but see if you can do number 2. All right, let me do this one. Hopefully you got a little bit of progress there without me. Let's see here. Let's see. What can we do? Well, the right side, Same trick. Cotangent is actually cosine of x over sine of x times cosine of x. Bring down everything else. All right, combine the fraction on the right, so the cosines multiply by each other. You get cosine squared over sine. Bring that down. Now we want to combine these two fractions, so the left part needs to have a sign in the denominator. So this one, we have to multiply by sine over sine. Let's see. That gives us sine times, oops, don't want to forget my variable there, sine x times cosecant x over sine of x minus cosine squared x over sine of x. All right, now a couple of things start to happen here. We are going to subtract the numerators, so the numerators are going to become 1. All right, one piece, not the number 1, but they're going to combine. But also right here, I can do a middle step right here. Sine times cosecant. Remember, cosecant is 1 over sine. So if I multiply it by a sine, those two cancel out. So this numerator is actually only 1. That numerator is only 1. So that will be 1 minus cosine squared x on the top. All right, so this numerator over here became 1, and then we subtract. Well, wait a minute, that should look a little familiar to us. 1 minus cosine squared, that is simply a derivative of this one, right? 1 minus cosine squared will be sine squared. So we've got sine squared on the top. And on the denominator, we've just got a regular sine. Hey, look at that. And so in the end, we are simply left with a cosine. Sorry, what am I saying? It's too early. What? Just at one sine. Sine squared on top. It cancels on the bottom. We've got sine. There we go. Sorry about that. There we go. So we're using the common denominator to combine the two fractions, and then we can apply our identities. All right, I got one more to do myself, then I got a few for you to try out as well. All right, so those first two were sort of, I won't call them easy. They're certainly not easy, but you only had to make one common denominator change. This one, you've got to make a common denominator change on both fractions. Okay, so if I want the common denominator here, my common denominator will be just the combination of both of these denominators. It will be 1 plus cosine theta times sine of theta. That's going to be my common denominator. So on the right side, what does this one need? This one needs a 1 plus cosine theta. So I have to multiply by that on the top and the bottom. What does this side on the left need? Well, that side needs a sine still, so I have to multiply that one by sine over sine. That will give me my common denominator. Okay, now I'm just going to write it as one big fraction because that's where we're headed anyways. So the left side, I've got these two, which is sine squared plus, all right, on the right, I've got this right here. So what happens here? The cosine distributes, right? So we've got cosine theta plus cosine squared theta. So that's in my numerator there. All right, time to keep going. What can we do here? Oh, look, I see it, I see it. Let me get a different highlighter. Let's try the green maybe. Sine squared and a cosine squared. Our old friends, sine squared and cosine squared. Hopefully you are starting to get that one imprinted in your memory. That is equal to 1. So we've got 1 on top, but there's still a regular old cosine divided by, that's on the numerator. What's in the denominator? We've got 1 plus cosine theta times sine theta. Hey, look at that. The numerator. Put that in parentheses just for clarity. That's also in the denominator. Those two cancel out. What? What a coincidence. It's almost like Mr. Bolt made this problem. What? All right, that cancels out, and you're simply left with 1 over sine, which is cosecant theta. All right, but the new thing on this problem was just having to get a common denominator by manipulating both fractions. All right, we had to multiply this denominator by the one on the right. We had to multiply this denominator by the one on the left. Manipulating both fractions there. All right, a little simpler today. I've got 4 problems I would like you to try out here. All right. Can I get them all nicely on the screen for us? There we go. Work together in your groups. If you want to do them on the whiteboards, that would be great. It would definitely impress the substitute with how amazing you are. But try these 4 out. They require you to make common denominators. Sometimes you'll only have to manipulate one of the fractions. Sometimes you're going to have to manipulate both of the fractions, but they should all simplify quite a bit. All right, good luck. Pause the video and try those out.